Okay, in this lab, we're going to go over what's called percent change. And the chart actually, the lab you're doing actually looks like this. The first page is essentially blank, I think just to jot out the definition and your notes and stuff like that. But as far as it goes for a definition, percent change, it's actually pretty straightforward. It is change over original. So as an example, suppose we have, say, there's a TV that costs $500 and then it goes on sale for $350. Find the percent change. Well, by definition, it's change over original. Original is the original price. The original price was $500, so that goes in my denominator. To get my change, the change is always the new minus the original. So in this case, the new price is $350 minus the old price, which is $500. Then you just throw it into your calculator. 350 minus 500 is negative 150 over 500. That's negative 15 over 50, which is negative 30%. You can just throw this in your calculator, convert the decimal to a percent, but you get negative 30%. And as far as it goes, all this negative means is that the change went down. It's negative percent change. Whether your answers should be positive or negative are entirely, in this class, it won't matter one way or another. Because I understand you can say it's a negative percent change, or you can write the negative. They're kind of interchangeable. I'm not going to speak for your 143 instructor and how they choose to write your answers. Some will only care about the percent change, so you won't worry about the negative and just say the percent change is 30%. Other times they'll want you to write the negative. But your 143 instructor should make that clear. For the purposes of this class, it doesn't actually really matter. But the idea is, this is negative because the price went down, so the percent change went down. It was negative. If we do another problem, say we have this. You buy a house where the cost is $100,000. After 5 years, it costs $130,000. Find the percent change. The original price is $100,000. The change, the new price is $130,000 minus $100,000. $130,000 minus $100,000 is just $30,000 over $100,000, which if you put it in your calculator will give you 0.3, which is 30%. And here again, this one is positive because the price went up. Mathematically, they're the same. It's a 30% change, but one is positive because it goes up, the other is negative because it goes down. And again, I don't want to speak for your 143 instructor as to how they want it written. They will make that clear for you. But now, just to run through a few problems on here, on the next page. Chris had 265 cards in his baseball card collection. He sold 183 of the cards to purchase a new iPod. What is the percent decrease in the number of Chris's baseball card collection? So let's see. By definition, the percent decrease is just the percent change. We know it's change over original. Original is the number of cards he started with, which is 265. Change is the change. Let's see. His number of cards He sold 883 of them. So that's the change. That's how many he changed. So the change is 183. Now I just throw it into my calculator. 183 divided by 265.69. 0.69, which we then know becomes 69%. And again, you can say the percent decrease was 69%, or you could say the percent change is negative 69%. They mean the same thing. Number 8, Kelly, an employee of the Limited, bought a sweater originally priced at $31.50 for $26.77. We'll say her price $26.77 after her employee discount. What percent off is the employee discount? Again, we're looking for percent change. The original price is $31.50. Here we have to be careful. I need to find the percent change. I need to find the change here. $26.77 is not the change. It's the price she paid. The change is actually the difference between the original price and the price she paid. Just like with our house, the difference between its new value and its old value. So here, I do $26.77, the new one, minus $31.50, the old one. And if we plug it into my calculator, 26.77 minus 31.50 equals my calculator just zeroed out. 26.77 minus 31.50 equals negative 4.73 over 31.50. So I just divide that by 31.50 and I get negative 0.150. So negative 0.15, which is 15%. So what's the percent change? What's the employee discount? 15%. The change in price over the original price. Last one. A manufacturing company with 578 employees must decrease their number of employees by 18%. How many total employees will the company now have? Well, here, this one is a little bit different. A manufacturing company with 578 employees must decrease their number of employees by 18%. How many total employees will the company now have? So it doesn't ask us to find percent change, but we're still using a percentage. But here we can go back to our old standby, use a proportion. If that's how many employees I start with, I need to decrease by 18%. So I need to find 18% of that. So I set up a proportion, 18 over 100, because that's my percent. This is the total number of employees, so it goes on the bottom. I'm looking for 18% of them. So the x matches up with the 18. I cross multiply. 100 times x is 100x. 578 times 18 is 10,404. Then I divide by 100. And I get x equals 104.04. Which, of course, we'll just say is 104. And now, again, one of the goals of this class is your ability to read a word problem, figure out what you're supposed to do, interpret the problem, do the math, and then make sure your answer makes sense. Here, this 104, that is not the number of employees that are left over. The question says, how many total employees will the company now have? This 104 is the change, the 18%. Those are the people you have to lay off. So how many employees will the company now have? You have to take the original number, 578, and subtract off the 104 you lay off. Then you get 474. And again, the point here is it's kind of a two-part problem. You use your understanding of percent change and what it means, and then you do something at the end. So make sure you're reading through problems carefully, understanding what you're doing, and make sure your answers make sense. And again, as I've said before, and I think all the videos, feel free to email me or stop by my office if any other questions arise. But when I post this online now, we have done the first page. Where is it? Oops. Well, you kind of lucked out. I actually went through some of the problems you're going to turn in because I have so many pages here. We skipped over the examples, but what you need to do are the problems that say practice right here. They're on the third page of the lab when you download it. Start with number 1 and go through 7, 8, 9, 10, 11, 12. 1 through 12. And yes, when you go through them, we actually solved out a few of them because I simply solved the wrong problems as I was doing this, which isn't a big issue.